Okay, so welcome back. In this playlist, we've been talking about data acquisition, and we've looked at some devices and we've written some code. And in the previous couple videos, we've used an Arduino to capture data. We've written a sketch on the Arduino, and also we've generated some C# code to grab a burst of data from the Arduino and to plot that in a C# Windows forms. Now, what we're going to do in this video is we're going to add to that, and we're going to do some logging in that C# application, and we're going to grab data from the Arduino, and in this case we got an Arduino Nano, and we're going to graph that on a chart in C# as the data comes in. Now, what is logging? Well, you can see here I've got my signal generator, and it's generating a 1 hertz, 1 cycle per second, 5-volt waveform. And it is feeding that to a potentiometer. And the Arduino, the Nano, is measuring the output of that potentiometer. And you can see it's a very slow moving signal. I've got it on the scope, I've got it in roll mode, and as the data comes in, it plots it on the screen. Now, logging is for capturing very low frequency stuff like this, and as you can see, as I change the potentiometer, the magnitude of the waveform drops. So if you can imagine signals like mechanical signals or pressures or temperatures that change slowly over time, logging is what you would use to gather that data. And you might grab a sample every half second or every second or whatever, and then print it or plot it or put it into a CSV file or whatever. So what we're going to do is we're going to modify our previous code, our previous Arduino sketch, and also C# code to add logging capability to the burst capability we entered before. So let's go take a look at the Arduino sketch and at the new application and take a look at it. Okay, so here is our new modified C# application where we've added logging capability. Now, I encourage you to look at the previous videos to see how we got here, how we planned this, what the previous code is based on, and what the Arduino sketch is. In this modified code, what we've added is basically everything here on the right. We've added 3 buttons, a log button, a stop button, and an open port button. And we've also added a combo box where you can select the time step or how often, how many seconds you want between samples for this log. So if I select 5, that says every 5 seconds I'm going to grab data from the Arduino. Or you can type it in yourself. That's why we use a combo box. You can select whatever you want. So we've got a combo box. We've got 3 new buttons. We've got basically an identical chart that we had previously. And that's about it. Now you'll notice that one thing we have modified is we have extracted the code to open our Arduino serial USB port. And we've made it a button. So I can hit, everything else is, all the buttons are disabled until I open the port. So I open the port and it was successful. It gives me a port open. And what I can do is select a time step every 100 milliseconds or tenths of a second. So now that I've got the time step selected and I've got the port open, I'm going to hit the log button. And you can see it automatically updates and scales, and I've got a sinusoidal waveform coming into this chart. So what I'm going to do is I'm going to move the potentiometer like I did before and see what the results are. So you can see that it gives us about the same results, and it goes up to 5 volts, and it's basically grabbing every tenth of a second, updating and auto scaling. So That's the functionality that we're going to add to this. So the next thing, let's go take a look at the modified Arduino sketch to see how we got here. Okay, so this is the modified Arduino sketch that now adds logging capability. And like we said before, we're going to be able to select from the C# application what time step or sample rate we want for this logger. So we're going to write some code here to also grab that data from the C# application so it knows how often to sample data. All right. So here's the basic sketch. Nothing has changed here with the analog pin. Receive value, that string is basically what we receive. When we receive data from the C# application, it's going to be a string. We're going to call it receive value. This integer is new, and it is going to be an integer representing what sample rate the C# application has requested. So it's integer, and it's going to be the sample rate in milliseconds for logging. All right. Now, these three haven't changed. They're for burst. I have changed the name. It was num samples. Now it's num burst samples to make clear that we've got bursting and we've got logging going on. So I differentiated. Now we have set this number of burst samples at 100 as a constant. Ideally, what we would do is we would set up the C# application to tell us how many samples, and we'll show how you can do that fairly simply. But right now we're going to just leave it at a set 100. So that's basically that. Now we've got the void set up. No change from previously. Serial begin 9600 baud. Pin mode analog, input A0. No change. You can also see we've got the loop, but I've also added two methods. I've extracted some code and put them into methods. And those methods are for burst. When I'm in burst mode, this method will grab a burst of data, those 100 samples of data, and send them to the C# application. That's all this method does. And again, as we mentioned before, it fills up the value and time arrays specified up here and fills them up first and then empties all of those values into the serial communication and sends it to the C# application. And that's all this does. This one is for logging. It grabs a single sample and sends it back to the computer. So we've got a burst method and a log method. Okay, so let's first take a look at the loop and see what it's doing. Now, I modified the loop so that the main functionality is to wait for a command from the computer. So it says if serial available, it waits until there is serial data available at the serial port. And if there is, it will read a string. Before it was just reading a single byte. Now we are reading a string because we're going to not only tell it we want, for example, a log, but we're going to tell it how often we want the log to happen. So it's going to be, for example, with the log, it's going to be L200 for every 200 milliseconds. And then we're going to parse that string to tell the sketch how often to do things. If the receive value starts with, for example, if the code is B100 for 100 samples, if it starts with B, we know that we're asking for a burst. Then we go into this little if statement, and it says string B. We're setting up a temporary string where it takes a substring from this B100 string. And this substring will start with the second character in the string, because this is 0 based. So if the string is B100, it will start with the 100, and it will extract that 100 as a substring and call it B. All right. Now, I didn't implement anything more about that. You can convert that to an integer and then define how many what number the burst samples are. I haven't done that. I've only done it with the logging, so feel free to go ahead and do it. But basically, all this does is it calls the grab, burst, and send method. And the grab, burst, and send method we talked about is not a lot different from what we had before. It basically reads from 0 to, in this case, 100 burst samples, and it grabs the microseconds and the value at the analog read pin from 0 to 1023 and puts those both into arrays, and then it immediately goes through and sends those values back to the computer. The time, comma, value, it sends it as a CSV string that's going to look like this with microseconds, comma, 0 to 1023 /r/n that we talked about before. And when it's all done with that, it's going to send an end command so the computer knows, okay, it's finished sending its burst. All right? So pretty straightforward, not much different from what we had before. Now, if the string it receives starts with an L, which means the computer wants to log, it needs to extract the number after the L, and that is how many milliseconds we're going to want for each sample. So the receive val substring, again, we do the same thing. We pull off the trailing number from this L200 or whatever. We pull off the trailing string and call it S. And then what we do is we convert that S to a float. So if it's like a 0.1, we convert that to a float, multiply times 1,000 to get milliseconds, cast that to an integer, and that gives us how many milliseconds we want for each sample. All right? And then it just says, okay, unless there is a S, which is a stop command from the C#, unless there is a stop character, we're going to grab a sample and send it. And then we're going to delay whatever this sample rate milliseconds is. We're going to delay that amount of time and then go do it again, as long as we don't get a S or stop command from the computer. So with the logging, it's just going to get into this loop, and the only way to get out of the loop is to have the computer send a stop command, and then it goes back to the loop here. So grab, sample, and send, that's very simple. It just defines a time where it gets the microseconds we talked about before, a value where it reads the 0 to 1023 from the pin, and immediately sends those back to the computer. Very simple method. So basically that's all it does. So if you want to modify yours, you can pause the video and type it in. Next, what we're going to do is look at the C# program and see what we got. Okay, so here we are in our C# Windows Forms application. And you can see we've added 1, 2, 3 buttons here. I called it BTN log, BTN stop, and BTN open port. You can see over here, that's how I generally name things. I basically copied and pasted this chart because it's almost identical. And I added a label that says time step and a combo box. And we did that so we can not only select from a drop-down, but also the user can type in a value. So with the combo box, you first set it up to have a list of things you want the user to select from. So you scroll down to items, and it's a collection. Click on the 3 dots, and you can see here I entered 5, 1.0, 0.5, and 0.1. Enter whatever you want, but those are the numbers that are going to appear when you drop down the combo box. All right. So I've got this combo box is CMB time step. I named it. You can name it whatever you want, but that's what I've got. So again, just double click on these 3 buttons to get the event handlers. We're not going to need an event handler for this. It's just going to be, we're going to read from it, and we've already got the exit button. So now let's take a look at the form. Now, you recall before I've got this input data processor. There's no change in this. I'm going to basically be using this in the same way as I did before. just to process data for the burst. Now, when we do the logging, I'm going to have separate methods in this main form to do that. You can do whatever you want, but I'm just leaving this as it was. Now, in the main form, I've got the same usings. I think the only thing I've added is system.drawing. And we're going to need that for, I can't remember what, but we're going to need it. Docs to do, like I said before, initializing. I did change this num samples to num burst samples just to clarify that it's being used in the burst code. But otherwise, I think there's no change. Now, in the form, I basically set up code so that initially when you start this up, all of the buttons are going to be disabled. So I set for the button read, print, plot, log, process, and stop enabled equals false. Later on, once we open the port, we're going to set these to true, but we don't want the user clicking on stuff when there's no open port. This chart 1, no change. In fact, I just copied and pasted that and renamed this for the second chart as chart 2. But everything else is going to be the same except for the title. I've got seconds. I'm not sure that's right. I think I may have to change that. But anyway, it's basically a copy and paste. So the initializing, not much change. Now, event handlers. These are the previous burst event handlers you've already got. There are some changes we'll talk about. And I added, we've got for these new buttons, we've got the log, open port, and stop buttons. We've added those event handlers. But also we've got an event handler for data received on the serial port. We're going to need this because we're going to set it up so that anytime the C# application gets data from the Arduino, you know, every half second or every second or whatever, it's going to initiate an event so that the C# application says, hey, I've got some data from the Arduino, I need to handle it. That we're going to set up in a bit. Methods that are used based on that. I've got a separate open port method, which I basically extracted the code we had before and have a separate method just to do the open port. The burst methods, we're going to take a look at those just to make sure there's no changes. These logger methods are new. So I've got a parse CSV logger, I've got a scale values logger, and I've got a 0 times logger. It's basically the same methods we had for the burst, but they're a little bit different, so we're using them just for the logger. So what we'll do is we will go through and see what the changes are. Okay, so now the first thing you do after the application opens is you click the button open port button. And here's the event handler, and all it does is it calls the open port method. Very simple. So let's run up to the open port method. Here is the open port method. And it's basically a copy and paste of the code we had before. You define nanoport, new serial port, 9600, COM8 in my case. You do a try catch, nanoport is open. If not, it gives the message box that says, dude, seriously, you need to plug in the device first. And once you've done that, I've added this if statement. And if the nanoport is open, if so, we're going to enable the other buttons. You can see down here, each of these buttons that was disabled, now we know the port's open, so we're going to set the enabled equals true. And also what I did is I changed the text on the button open port to port open and changed some colors just so the user knows, aha, the port's open, the buttons are enabled, we're good to go. All right? So now once you've got the port open, you wait for the button log event handler. Okay? So the port's open and the user clicks on the log button. Again, that's this button right here. So that's the first thing you do after you open the port. And the log button, all it does is it writes to the port the L that says, okay, I want you to log, and it concatenates whatever is in this combo box for a time. Okay, So remember, this is going to be like a 0.5 or a 1.0 or whatever. So it concatenates that number to the L and sends it out to the nano. And then the nano reads it and parses it and figures out what the time step is. We are also initializing, or we are subscribing to a data received event, right? And we're setting up a data received event handler, and that's going to be down here. You can see right here. You got the data received event handler. So the way this is going to work is every time the Arduino sends data, it's going to initiate an event, and it's going to go to this event handler, and the C# program is going to be able to deal with it. So that's the button log click, and then the process goes to this event handler. So let's take a look at that. I am defining the serial port as whoever sent the event. So that's the sender. So SP is the serial port that sent the event. And then what I'm doing is I'm reading a line. Before we just read one character, here we're going to read the line again because it is a string. And the string is called, we're going to call it input data. Now, one thing to keep in mind when we're doing logging that was different from when we were doing bursts is we don't need arrays. We just need a time and a value. For each set of data, each time step data that we received, all we need is two numbers, a time and a value. So it's a lot easier. We don't need to go to this input data processor with all the arrays and everything. We just need to extract the values. This is when we call this new parse CSV logger. We take that string that was received, which is a number, comma, value, and we send that to the parse CSV logger, and it returns two integers called integer samples, and we're putting it in a two-element array. So it's a time integer and a value integer, okay? And we can look at what the parse CSV logger is, but basically you can see that it converts from a string to two integers of time and value. Then all we do is we take that integer array, send it to this 0 times logger, which operates on the time value, the 0th value, and it gives us a double. And then we send it also, that int samples array, to the scale values, and it takes the value element of this array, which is a 0 to 1023, and converts it from a 0 to 1023 to a 5 and gives us a double in return. So now we've got an X value as a double, a Y value as a double, and all we need to do is send that to our chart 2. And again, like we did last time, keep in mind that this chart is on a different thread from this data received event handler. So we have to do this invoking a delegate like we did previously. So we do a chart2 invoke, new method invoker, and the delegate is this chart2 series, and it's series 1, and we add X value and Y value to it, okay? So you got to do this because it's on a different thread. So really it's pretty straightforward. We're just parsing, getting some doubles for the time and the value, and sending that to the chart. Now let's run over and look at the parse CSV logger method. I'm not going to go through these in too much detail because it's about the same as we had before, but you know they're not working on arrays. So parse CSV logger, it takes in a string, which is the two numbers separated by a comma, and it makes a new int array, a two-element int array called vals. And again, we did like before. We trim the carriage return line feed characters, and that gives us a string. And then we split that based on the comma and put it into a substring array, two-element substring. And then we try to parse it. And if it fails, we just make it a value of 0. If it's successful, it sends out to this integer, two-element integer array. It sends out the 0th element, which is the time, and the 1th element, which is the value, and returns that as an integer array. Pretty straightforward, not too different from what we had before. Now the scale times or scale values logger, we've added that we feed in the 2-element logger samples integer array, and it basically does the same thing as we did before. Converts the range to double, converts the sample value to double, and then multiplies times 5 and returns a double for the value. So I'm not going to go through that in too much more depth. And then the 0 times basically takes in that logger samples array of 2 elements. If it's the first sample, then it will use that value of time, which is a big microseconds integer, and it will subtract that from all future values so that it's 0 based. And then we do the same as before. We get the time in milliseconds by converting that to a double, multiplying times 0.0001. Actually, it's in seconds. And then we increase the sample count and return the time in milliseconds. Okay, so I think that's about it. Just keep in mind, one of the things I've found to be the biggest challenge was making sure that the string data you receive from the Arduino, you've got all the characters and empty spaces and everything figured out and accounted for. Otherwise, you can get some strange numbers. But otherwise, I hope this helps. Take care and have a really good day. Thanks.